Another way for you to perform the mechanical analysis on the truss structure is by using the method of section. Sometimes we are only interested to study certain members of the truss, not all. So you can use the method of section to selectively section out the members that you want to study. Section out the members means you have to create an imaginary cut on the members of interest. Let's look at the illustration. So, as you know, a basic truss structure may consist of thin members connected to one another at the joints. Okay, if we take out one slender member based from our previous exercise, we know that there will be a pair of reaction forces at each end of the member like this. So, let's just assume the force to be in tension state as shown. So, using the method of section, imagine like you are cutting the middle section of the member. If it is being cut, then the single member will be separated into two separate features, which exposes the internal force occurring within the truss member. The internal force, which is drawn in the red coloured line, should comply to the equilibrium condition of the structure. Dalam erti kata lain, if at one end of the member it is pointed upward, then the internal structure will point downward macam tu. It should be in a balanced condition or in an equilibrium condition. The method of section is very useful when working with large structure like this. In real engineering application, probably you are more interested to know the force at certain truss member only. For example, if you want to know the force of the truss member located in the middle of the truss structure, then you can just section out the middle part like this. You can work out the structural analysis either from the left side of the truss structure or from the right side of the truss structure. Okay, so in this particular example, you are required to find the force in members GE, GC and BC only, which is these highlighted members. So you don't have to use the method of joints to find all the forces in all the truss members. So in order to do that, we can proceed using the method of sections. Using the method of section, we section out or we cut off the members that we are interested in, which is the GE, GC and BC member. So the first step in solving using the method of section, as usual, is first you have to define the support reaction forces at each joint. Okay, so you know at joint A, it is a pin type of joint, so there is one reaction force in Y direction and one reaction force in X direction, whereas in joint D, it's a roller kind of joint, so there is only one reaction force in the Y direction. Okay, now we are going to apply the equilibrium condition to find the magnitude of all the external forces dulu. Okay, we are not dealing with the sections yet. We just want to know the magnitude of all the external forces. So in equilibrium, let's start with the X direction first. Summation of all forces in X should be equal to 0. So there is one force in the X direction, which is this 400 Newton, and then another force in X direction, which is this negative AX, equivalent to 0. So AX would be equivalent to 400 Newton pointed to the left. Because the magnitude is positive, it means that our initial assumption is correct. So we are not going to apply the equilibrium condition in Y direction yet, because there are two unknowns in Y direction, which is this AY and this DY. So if there are two unknowns, then we cannot simply solve it with a single equation. So instead, I'm going to apply the equilibrium condition for moment at point, let's take it at point A. Okay, so assuming counterclockwise direction as positive, summation of moment at point A should be equivalent to 0. Sorry, ada tersilap tulis dekat situ. It's supposed to be MA, okay, not MB. Now, so recall the formula for moment. It will be force multiplied with the perpendicular distance to the rotation point. Okay, let's calculate the moment caused by this force. The force is 400 Newton and the perpendicular distance to the rotation point A would be 3 meter. So draw an imaginary circle around the rotation point and you will get the direction to be clockwise direction. So if it's clockwise, it means the magnitude of this moment is negative. Okay, now the moment caused by this force, the force is dy, and the perpendicular of the line of force to the rotation point is 12 meter, 12 meter. And if you draw an imaginary circle around the rotation point, the direction of this force is counterclockwise manner. So the magnitude would be positive. Okay, for force AY and AX, it will not cause any kind of movement because the line of force passes through the rotation point. Okay, so this should be very basic. You should master this very well. Okay, don't forget that there is an additional force over here, which is this 1,200 Newton, okay? And the perpendicular distance of this force to the rotation point is 8 meter. So if you draw an imaginary circle around the rotation point A, you will get the direction of moment caused by this force to be in a clockwise manner. So the magnitude of this particular expression would be negative, okay? So, as there is no other forces that you need to solve for, so the summation of all these elements should be equivalent to 0. So as there is only one unknown in the equation, then you can easily calculate for dy to be 900 Newton. And if it is positive, it means that the assumed direction is correct, which is upward direction. Okay, now finally, we can proceed our analysis by considering the equilibrium condition in the y direction. So, summation of all forces in y equivalent to 0. There are two forces exist in y, which is the AY. It is positive because it's pointed upward. And the dy, we already calculated earlier, which is 900 Newton. Okay, and also don't forget the 1,200 Newton pointed downward. Okay, so it will be negative because it's pointed downward. So all the expression of this particular equation will become 0. And as there is only one unknown in this equation, so we can easily solve for AY. It will become 300 Newton. And if it's positive, it means that our assumed direction is correct. It is pointed upward. Okay, now for clarity purpose, I'm going to clean up my image over here. Banyak sangat sketching. So, I am just going to put only the necessary information in this particular diagram, which is the external force that we have calculated earlier. Okay, so we already know that AY is 300 Newton pointed upwards. The AX is 400 Newton pointed to the left. And the DY is 900 Newton pointed upward. Okay, now we can apply the method of sections to get the forces in a very specific truss members as requested in the question. Okay, you are going to section out the truss into two parts, okay, which actually cut out the member GE, GC and also BC. So you have the choice whether you want to proceed your analysis from the left side of the truss structure or from the right side of the truss structure. So which one do we choose? So the tips in solving using the method of section is that you choose the side where there are less number of forces. For example, on the left side, there are only 2 external forces exist, okay? Whereas on the right side, there are a total of 3 external forces exist. So in a way, we are going to choose the left side because it have the lower number of forces. So less items that we need to deal with in our calculation. Okay, so now let me just redraw the left section of the truss structure so that the internal forces at the respective members are exposed, okay? So we have joint A over here, joint B over here, and also another joint G over here. So this joint G is connected with the truss member to joint E and also joint C, and this C is also connected to joint B through the truss member. Okay, now let us draw the truss member connecting between each joint. Okay, so there is a truss member connecting between joint A and joint B, another truss member connecting joint A and joint G, and then another truss member connecting between joint G and joint B. Okay, so there is a truss member connecting between joint G and E. Tapi ingat, kita dah potong dia kan, so kita draw it only halfway sahajalah. And also there's another truss member connecting between G and C, but we already section it out. So let's just draw only the half part of it. And finally, another truss member connecting joint B and C. Again, similarly, we already section it out. So we just draw only one half of the truss member. Okay, now let us just draw the direction of the forces acting at each joint. So there is one force of 300 Newton acting upward at joint A and another force of 400 Newton acting to the left side at joint A. Now the external forces are done. Let us proceed with sketching the internal forces of the truss member at the area where we have sectioned out. Okay, so we know that the truss member GE has already been sectioned out. So let's just assume the internal force connecting between joint G and E is in this direction, and we'll call it FGE. Okay, and also section BC have been sectioned out, so the internal force are being exposed, and let's just assume the direction is this way, and we're going to call it FBC. Okay, and finally there is an internal force between the section of G and C, so let's just assume the direction to be in the same direction of the beam, definitely, and we are going to call it FGC. Okay, before we proceed with the analysis, if you notice, there is one sengit-bengit punya force direction over here, so we need some additional information related to the angular displacement between the truss member so that we can resolve this sengit-bengit punya force into an equivalent X and Y direction. Okay, now let's look at the original image. Okay, if I were to sketch the triangle following this truss member, the magnitude over here would be 3 and the magnitude over here would be 4. So you see, based on the trigonometric punya rule, so if this is 3, this is 4, then the length of the hypotenuse would be 3 kuasa 2 plus 4 kuasa 2, and then square root all that summation. So you will get a magnitude of 5. So the angular information related to this area would have a magnitude of theta over here, and this length would be 3, this one would be 4, and this one would be 5. Now we have embedded the necessary information. The next step is for us to resolve this FGC into an equivalent X and Y direction. So in the X direction, it will become FGC multiplied with 4 over 5. Kenapa 4 over 5? Because this 4 over 5 is the sine theta of this particular member. Okay, so again, accordingly, if I were to resolve this into the Y direction, it become FGC over cos theta. Cos is sebelahan. The sebelahan of the theta is 3 and the hypotenuse is 5. Okay. Okay, now we can apply the analysis process to solve for the internal forces. Tak susah pun, teknik dia sama je. You just need to apply the equilibrium condition so that you can calculate the magnitude of FGE, FGC and also FBC. Okay? Strategically, when solving using the equilibrium condition, you start at a direction where there is the least number of unknown in that particular direction. Okay, for example, in the direction of Y, there is one unknown, which is the FGC sahaja. So if there is one unknown, then we can easily solve for that particular unknown. Okay, so if we apply the equilibrium condition in the Y direction, taking the upward direction as positive, summation of all Fy should be equivalent to 0. We know there is a force pointed upward, the magnitude of 300 Newton, and there's another force pointed downward. So it will become negative FGC multiplied with 3 over 5. The summation of these two entities will become 0. So you can easily solve for FGC. Use your calculator and you will get the magnitude of FGC to be 500 Newton. So if it is positive, it means that our assumed direction is correct. Okay. So if I were to draw the member GC like this, so let me just redraw the member over here. The direction of FGC at one end will be pointed outward, so the direction at the other end would be in the opposite direction. So if you look at this particular pair of force, it looks like it is stretching the member GC longer, kan? So it means that member FGC is in a tension state. Okay, let me just put the magnitude over here, 500 Newton in tension state. Okay, the next step is we can't really apply the equilibrium in X direction just yet because right now we have two unknowns, which is FGE and FBC. So if there are two unknowns, we still can't solve it yet. So probably the most convenient way for us to solve this is by applying the moment. At which point should we apply the moment? Okay, we are going to apply a moment at a point where there are many unknown forces acting on it. Okay, so in this case, I'm going to apply the equilibrium condition of moment at point G. So, applying the equilibrium equation, summation of all moment acting at point G should be equivalent to 0. So, let's recall formula for moment is F multiplied with D. Okay, let's find the moment caused by this particular force. Okay, the force magnitude is 400 Newton. And the perpendicular distance of this line of force to the rotation point G is 3 meter. Okay, refer to the original diagram. Okay, if you draw an imaginary circle around point G, then you will see that this line of force will create a clockwise kind of moment. So, therefore, our magnitude will become negative. Okay, now let's find the moment caused by this force. The magnitude is 300 Newton and the perpendicular distance from this line of force to the rotation point G is 4 meter. Refer to the original diagram again. And if you draw an imaginary circle around rotation point G, then you will get the direction of this moment to be in a clockwise direction as well. So if it is clockwise, then the magnitude of the moment will be negative. Okay, now let's find the moment caused by this line of force. This FBC is unknown and the perpendicular distance is 3 meter. Okay, so if you draw an imaginary circle around rotation point G, you will get the direction of this moment to be counterclockwise. So if it's counterclockwise, then the magnitude is positive. Okay, as for the FGE, it will not create any moment at point G because the line of FGE passes through the rotation point, okay? Accordingly, FGC also will not create a moment at point G because that line of action, that red line, is passing through the rotation point G. So we can eliminate these two identities in our equation. So the summation of everything that we have defined earlier would sum up to 0. Okay, so as you can see from this equation, there is only one unknown, which is FBC. So you can easily solve for FBC using your calculator. And you will get the magnitude of FBC to be 800 Newton. Okay, so if it's positive, it means the assumed direction is correct. Okay, so if I were to redraw the member BC like this and I sketch it like this, the line of force of FBC would go outward. So accordingly, the force at the other end would be in the opposite direction. So you can see the combination of this couple force will create a tension kind of effect. Okay, so I'm going to put a remark over here. So the magnitude of FBC is 800 Newton and the state of this BC member is in tension. Okay, so there is only one unknown left, which is the FGE. So then simply you can apply the equilibrium condition in the x direction pula this time around. Okay, so summation of all the forces in x direction will be equivalent to 0. There's one force over here with the magnitude of 400 Newton. As it is pointed to the left, then the magnitude of 400 Newton become negative. And then there's another force in the x direction over here, which is 800 Newton. The direction of the force is to the right, so the magnitude is positive. And then don't forget there is another force over here, which is the FGC multiplied with 4 over 5. But remember, we already found that the FGC magnitude to be 500 Newton. So we can substitute that 500 Newton darab dengan 4 over 5. And finally, the unknown here, which is FGE. Okay, as it is pointed to the right, then the magnitude is positive. So ada lagi tak any forces acting in the x direction? Kalau tak ada, then the summation of all this expression would be equivalent to 0. So as there is only one unknown, so we can simply solve for FGE, whereby the magnitude of FGE will become negative 800 Newton. Alamak, if it is negative macam mana pula? If it is negative, it means that the actual direction of the force GE would be in the opposite direction. So basically, the magnitude is 800 Newton. And if I were to redraw the member GE like this, then the actual direction of FGE would be pointed towards the GE member. Okay, at the opposite end also, it will be in the opposite direction to ensure equilibrium condition. So as you can see, this pair of forces will create a compression kind of state. So therefore, the magnitude of our FGE is 800 Newton and this particular member would be in compression state. Okay, dah siap. Okay, as I almost exceeded the 20 minutes duration of a short video requirement, then I'm going to show you the following example in the next short video. Okay, so stay tuned.